Let's get started. So first of all, if we want to find the area of the trapezoid, right? So what's the formula for the area of trapezoid, Sam?
I don't know.
The area equal to the top plus the base times the height and divided by 2. All right, so that's the formula given to you in the formula sheet in the exam. All right, but it's good for you to know it. So how do we find the areas? We need to know the top, which is this one, the dotted line, and the bottom is the 2. And we don't know the top, we don't know the height. So what we can do is that we can use trigonometry to find out. Okay, so if we draw a vertical line here, so that is the height. Okay, and we know this one is, so now it's a right angle triangle, and we know the hypotenuse is 2. How can we find this one? Because we know this is theta, right? Which means this guy is theta as well. So I noticed you guys were doing like this one, which is like 90 minus theta, which is okay, but it would just make your working a little bit more complicated, right? So if we use this theta instead of this guy, that would be much easier and much neater.
Yeah.
So if this is like theta, and we know the hypotenuse is 2, how do we find this one? So this is O, and this is A, and this is H. Okay, so that would be, if we want to find O, we're going to use sine. Sine theta equal to O over H. Yeah?
Yeah.
So, therefore, O would become 2 times sine theta. Yeah? That is the hypotenuse. So, which means the height is 2 sine theta. Does it make sense?
Yeah.
And we're going to use the same strategy to find out the A here. And then if we find out this one, and this is similar, it's actually equal to that one, and we know this one is equal to 2.
Yeah.
So we just plus these three guys, and then we can find out the top. So this one is A, and this is H, so we're going to use cos. Cos theta equal to A over H. So the H is 2, so therefore adjacent will equal to 2 cosine theta.
Yeah.
Yeah, so this one is 2 cos theta.
Yeah.
And this one, therefore,
It's also 2 cos.
2 cos theta, and this is 2. So now we have everything.
Yeah.
So the area would be the top, which is 4 cos theta plus 2, and that's the top.
Wait, what now?
Because 2 cosine theta plus 2 cosine theta
Oh, yeah.
Wouldn't it be 4
cos
cosine theta?
Yeah.
plus 2,
Plus
and
2.
that's the top,
Yeah.
plus the base,
Plus
The
plus
2.
2, yeah.
and times the height, which is 2 cos theta, sine theta.
Sine theta.
And then divided by 2, which is,
Times 1
I
over
can just
2.
cancel this 2 out, but let's just put it this way.
Yeah.
Okay, so that is the area.
Yeah.
So now the question is asking, how can I make the trapezoid having the largest area? So when we talk about the maximum minimum question, we're going to differentiate the function and make the gradient equal to 0.
Yeah.
Alright, so what we can do now, if we use our CAS, we just differentiate this guy using our CAS, and then you get something, and that equal to 0, and then you solve for that, right, using our CAS.
Oh my god.
Alright, so now we pop the equation on the CAS. And remember, don't put any y equal to something. You just need to put the expression after the equal sign. So you don't need to put, a lot of students go y equal to something. You don't have to, because in this case, it looks neater. Okay, so, and also I know you can simplify. For example, you can cancel the 2.5, but I just want to put exactly what we got on the board so that people don't get confused. All right, so now what we're going to do is that we're going to define the function. Always remember define function, because otherwise when you got a lot of things here, it looks so messy. But if you define it, it will be much neater. Okay, so what we're going to do is that we're going to highlight this whole thing, and then we go to interactive, and then we go to define. Okay, so okay. All right, so now fx done. Okay, so which means fx can represent the whole messy function. Okay, so what we're going to do now is we're going to differentiate this guy and make the gradient equal to 0, because that's how we find the maximum minimum, which means stationary points. So we're going to check this down, and then we highlight it, and then we go to interactive, calculation, and differentiate. Okay, and then just okay. All right, so we get very complicated here, but it doesn't matter. So we just need to make the gradient equal to 0. So we go backward. I know some of you might copy the whole thing down, but I wouldn't suggest you to do so, because sometimes when you want to highlight it and copy it down, sometimes you only copy part of it. You don't copy the whole thing. So that happens a lot. So what I would do is that I just go back and then put equal to 0 here, and then I'm going to solve for that. So advanced, solve. Okay, I know I can't solve it because it's a general solution. So what I'm going to do is that I'm going to put the domain here. So the mesh 3 and the vertical line, and that's where you find the vertical line, mesh 3, and then third row, and then you put what's the domain here? So that one, it's the angle, it must be from 0 to 100 degree. So because remember the mode, here we are using radians. So radians means we're not saying 180 degree, we say pi. Okay, so the domain will be 0, less than x, and less than pi. All right, so now we can solve for it again. All right, there you go. So when x equal to pi or x equal to pi over 3, you will have the either maximum or minimum. So how do you determine which one is maximum minimum? Okay, so we use second derivative. So we can, this guy go down again, and then we second derivative. Okay, so order change to 2. Okay, and then we get the whole thing, we copy this down, and then we want to divide it. So remember, don't divide fx, don't divide sf, because you already got fx. So let's use another thing, let's use h. Okay, so h is this one, it's the second derivative. So now we have two solutions, but we don't know which one is maximum, which one is minimum. So we can replace the x with the first one, which is pi. Okay, and then you know it's 0. Okay, and then the other one, if you put pi over 3, okay, copy. If this is pi over 3 and paste, you have a negative number. What does that imply? It implies that you have a local maximum there. So which means pi over 3, when x equal to pi over 3, when the theta equal to pi over 3, the trapezium has a maximum. Okay, so that's what the question is asking. So when x equal to that, you will have a maximum. And then how do we find the maximum area? We just need to sub x equal to pi over 3 into the original function. So original function is fx. Okay, fx, copy and paste. All right, so change this to this one. So now you have a maximum area, which is 3 and root 3.